Okay, oh, let me. Okay, so our next job is we have to so we have a bunch of relations. We've seen, and already we have some useful ones like we have the Cartesian product, but some of them are special, and those are the functions. Okay, so what is a function? Okay. Okay, and we'll define a function. Like instead of starting with a function and then defining the graph, we'll just say like the graph of the function is the function. Okay. So we will define functions by their graph. Okay. So for example, instead of defining f of x equals x squared for all x, you'll just say that f equals its graph roughly. Okay, it doesn't really, okay. Then here's the graph of y equals x squared. Okay. It's not a good idea to define make a definition by picture. So this picture gives us the idea, the actual definition of f. It'll be all the as x ranges over all real numbers. Okay. Instead of, so this is the function f of x equals x squared. Instead of like sine theta, the sine will be the ordered pairs like what? Y, such that, I mean, here I can't avoid drawing a picture. So sine is supposed to, so the sine of theta should be like this, I hope. Okay, so like the sine of theta is, except we have to make some like consideration for when theta, goes past like this line, stuff like that. But let's not think about it too much. Okay, so satisfying some property. Okay. So functions will just be like special kinds of relations. Okay. So let's try and make our definition. So let f be a binary relation. F is called the function. If, okay, actually I'll just, does anyone have an idea of what I should put? Actually, I'll ask you for the name of this. Okay, can anyone tell me that? a test for testing if something is a function, or testing if a graph is the graph of a function. Yeah, vertical line test. Okay. Isn't it funny that when you first meet functions, you have this vertical line test, but you know, it's viewed as this wishy-washy thing, but this is how we define what a function is. Well, you just have to trust says is that when you draw a vertical line, you want it to meet once and only once. So you just have to say that it doesn't meet twice. Okay, so what does that mean? How does it mean? How would it meet the graph twice? Okay, so AB, okay, if for all A, B, and B prime, if AB is in F, then B equals B prime. Meaning that if I have two possible definitions of F of A, well, they have to be the same definition. Okay, that's what the vertical line test is saying. It's saying, well, it also says something else too, but let's not worry about it. Okay. This is just a vertical line test translated into our language. Okay. And then if you go back to like first year and you as something satisfying the vertical line test, you know, you wouldn't, actually they might believe you, but you shouldn't tell them that. Okay. Okay, so yeah, we've kind of done everything backwards. Functions are really graphs satisfying the functions are supposed to have things like domains and ranges. Luckily, we've defined the domain and range of any relation. So first we draw the graph, then we say what the domain and range is. Okay. Which is just completely backwards from how we would normally do it. Okay. So here's just some notation. Let F be a function. Okay. So if A comma B is in F, we just write F of A equals B. Okay. A is called the argument. B is called the value. Okay. Suppose that A and B are sets such that the domain of F equals A and the range of F is a subset of B. Then we write F goes from A to B. Okay. Okay. The domain, like, yeah, we might say like F maps A into B if the range of F is actually equal to B. We say F maps A onto B. Okay. And I think this definition of function is nice for the reason we clearly see, like, I don't know, we clearly see when is a relation a function? It's like there's like some we see that the domain of a function comes from the function itself. It like not the other way around. Just a quick example. Now to write down a function, I just write down a set of ordered pairs. Okay. And now in order to have a function, I can't write the same thing in the first coordinate twice. Okay, 1 gets sent to 2. Maybe 2 gets sent to alpha. And then maybe alpha gets sent to A. And then maybe F gets sent to A. Now I've written down a function. In order to have a function, I just need to make sure that I need to do the vertical line test. Each first coordinate appears only once. Okay. Now, the domain of F was just a set of the things like 0, set of things that occur in the first coordinates. And the range of F, that's a set of things that appear in the second coordinate, 1, 2, alpha, A. Okay. This is a function. And then we write things like f of 0 equals 1, f of 1 equals 2, equals A, f of little f equals A. And we can study like the properties of this function. We can do all the things we normally do with functions. Well, it's a lot, so it's getting past when I wanted to stop. But what a function is, and we've built them up with Cartesian products, so I don't have to tell you this like kind of wishy-washy thing of like, when is a function well defined? Well, you need to worry about if it's defined in 2 ways. Is it the same way? Everything. A function is a set of ordered pairs, and like if A, B, and AB prime are in the set, B equals B prime. Okay, that gives you like a very concrete way to decide if something is a function or not. Okay, and now we want to do the usual things with functions. We want to say when are two functions, when that makes sense. Let's see, what else do I want to do? We want to talk about F inverse. Well, like F inverse is a relation. We want to talk about when is it a function on the inverse of F. Okay. And then what we need to do is collect all the functions from F from A to B into a set. Okay, and that is our plan for the near future. Okay, so equality of functions, composition, and the set of all functions from A to B. That's our kind of, that is what you for functions. We need to talk about basically things like equivalence relations. And then I believe we can move on after that to the next section. Okay, thank you for making it through today. More definitions to come. Okay. That's it. So I'm gonna stop recording, but let me know.